Hi guys, today we are looking at Biotech Part 1, Viruses and Gene Technology, and we are on page 394 in the Campbell book. And for those of you at home, this is what that looks like. It's just a picture of some different viruses. We're going to start the first part of the notes. The different ones here. I know they all look funky and weird. All right, so the vaccine. All right, who wants to tell me how the two vaccines that are being used in the U.S. right now, how they work?
They use mRNA.
Okay, so they're both mRNA vaccines, the Pfizer and the Moderna, I think so it's pronounced. Both of them use mRNA, and so what is in the mRNA?
What's in the mRNA?
I mean, what does it code for? Well, so mRNA is obviously a code for a protein. So what's it coding for?
It's coding.
How does it work? How does it prevent people from getting COVID? I'm giving y'all the simple version, by the way, because that's the only one I can articulate.
Doesn't it code for the proteins on the outside of the cell?
Yeah, so if you look, good, Miranda, if you look on 394 here, probably the one that the COVID or coronavirus looks closest to would be the influenza one there, just because of the spikes on the outside. Does anybody know what corona means?
No.
What language is that? Spanish, Latin, something? Corona? Y'all have heard of the beer, right? Mm-hmm. You ever seen what's on the beer can or bottle?
Like a tree.
Crown. Like a crown for a king. And so the coronavirus is named like a crown because of the spikes on the outside and kind of the way it looks like kind of like a crown, I guess. And so that's where the name corona came from. And so anyway, yes. So what did you say, Miranda? The mRNA is coding for a protein on the outside of the coronavirus. So basically what's going to happen is you're going to get, if you get the vaccine, you're going to get injected with some of that mRNA. It's going to go into your body. It's going to go into your cells. And I don't know about all the transport and stuff that takes place there, but you're going to get injected with enough where some of your cells are going to start to make the proteins that are on the outside of that virus. Now, what are viruses made of? This is on number 2 and 3 in the notes there. What are the two main components of a virus? DNA or RNA on the inside. What are those candies that are like squishy on the inside? Gushers? Gushers? Yeah, so it's kind of like DNA or RNA is on the inside. I don't know how gushy it is, but anyway. And on the outside is, what do we call that? Well, it's on the outside of every virus. Protein code called a
Virus.
capsid. Good. So the viral envelope that's on the outside. The primary purpose of the viral envelope, the protein on the outside of viruses, is to do what?
It's to like trick the cytoplasm of the cell to let it in.
Okay, so the proteins on the outside of the virus act like a what?
Ligand.
Yeah, I was going to go for Trojan horse there. They are docking with it in cases, and so the cell has to identify it because the cell is constantly taking in different proteins and different macromolecules. And so the outside of that virus is like, hey, I'm a protein that you need, and hey, take me in. And then, oh, I get inside and like, oh, I spill my DNA or RNA out, take over your cell, make a bunch of copies, and then take over your body and kill you. So that's typically how this virus works, or make you very sick. So what they've done here is they basically made the the code for the part of the outside of this coronavirus. So your body takes it in, your body sees that mRNA, it makes that outer part of the virus, okay? And then your body's like, then that protein is released, and your body's like, hey, that's not supposed to be here. That's a foreign object. It's not good, and so your body has the specific immune response that we talked about back in the fall, where it starts to make plasma cells and antibodies, cytotoxic T cells get activated, and then memory cells get activated. And so in the future, if you're exposed to the actual coronavirus, then it recognizes what it looks like on the outside, and it already has all these memory cells, so it's able to fight it off much more quickly.
So
Okay? Yeah.
it's basically just exposing the body to that, like, those proteins without
Exposing it to the actual virus.
Okay.
Because the virus is gonna go into cells and is gonna affect them, and that's why we see all these odd symptoms. There's a lot of strange symptoms. Some are neurological. Some are someone that works at school I talked to the other day was telling me that their smell still hadn't come back, I think, and it'd been 2 or 3 weeks since they had it. Their taste had just come back. So I'm sure y'all probably heard about this in people where smell and taste and neurological, and there's like what they call bubble toes or blister toes, or maybe I'm thinking too much Jack Johnson. They had a little red toe. A lot of people had red toes from this earlier on was a symptom. Some kids had heart issues. Yeah, Miranda?
Oh, I was just gonna say, like, to get your taste back, I've heard that you can char an orange and then, like, squeeze out all the insides and put it with some brown sugar and then drink it.
Yeah, I heard that about the charred orange. I don't know what the science would say behind that, and I don't know how effective that is. Have you known someone that's actually done it?
No.
Okay, that's a good question. I have read that on the internet too. I don't know how effective that is. I would suspect if you cannot smell or taste something, there's plenty of articles online that explain this, and I haven't read them thoroughly enough to explain it to you, or don't remember. I read one of them one time. But it's actually affecting like some neurons and how they're functioning there. So they're not transmitting that signal for whatever reason. And there's a reason for it. I just can't remember it right offhand. So anyway, that's what the vaccines are doing. So as you guys are going into the spring and you're around, I'll be honest with you, y'all don't tell your parents this. Unless your parents are in medicine or have an extensive background in science, I would expect y'all probably are more familiar with the immune system and how this vaccine works than they are. And so it's your job to educate them on, you know, how it works. There's a lot of propaganda and stuff going around. My brother is still convinced that the nanobots are in the vaccine and they're going to be injected into him, and it's going to upload Mark of the Beast data to his phone, and that's the only way he's going to be able to buy and sell goods on, you think I'm kidding, but I'm not. This comes from a person who delivers his own babies on his bed in a tarp. But anyway, maybe it does contain that stuff. I haven't verified it, but I'm doubtful. Mostly it's supposed to be mRNA, so that's how it works. Now, I did read, as y'all were working on the lab today, on the protein synthesis lab, I read about, there's a new vaccine that Johnson & Johnson's coming out with that is not an mRNA vaccine. It is a weakened form of a cold virus that has some of the genetic material from Corona or COVID-19. And basically it's using that as a transport. And so it's got a weakened form of that virus. Your body is going to make an immune response just like it would to a cold or anything else. And then I guess there's enough of that COVID-19 on it to have an immune response and to generate memory cells and stuff. Now, it's in the early stages. The benefit of this over the Moderna and Pfizer vaccine, how many of those you got to have? 2. From what I've read, the efficacy rate or how like effective they actually or how they do what they're supposed to do is only about 50% after the first shot. And I think maybe that has to do with like when you're injecting with mRNA, maybe it doesn't make a lot of that. I don't know how much is actually produced, but it only is about 50% effective. And then so after the second dose, a few weeks later, then that's supposed to be where you get your like 95% immunity from. Okay. So the Johnson & Johnson, they didn't give a number on that one, but they were hopeful that you could just have one shot and it'd be as effective as the others. Just because of, I guess, the exposure or something a little more substantial early on, which would be helpful when we're trying to vaccinate how many ever millions of people decide to take the vaccine. In Alabama, there's already more people signed up than we have doses anywhere close to be given. So it's just a matter of the logistics of getting it out. And I think in Alabama, they had about vaccinated, I want to say 80,000 people, and they had like 260,000 vaccines. So across the country, many states have been very slow at getting their vaccines out, just because a lot of nurses and people in hospitals are busy with COVID patients because numbers are really high. And I think a couple of days ago was the highest death toll they've had. I think it was about 4,000 or 5,000 people died in one day. I want to say maybe 40-something hundred. And so they just really don't, I think, have enough people and logistics to get everything out like they need to. So hopefully we'll get that sorted out soon enough. And as soon as the vaccine comes in, people that want to take it can get it. And the reality is, like, even if some people don't want to take it, well, by the time you talk to people who have gotten it and then people who have gotten the vaccine, then you've gotten closer to some type of herd immunity where when you go out, you're much less likely to encounter someone that might have it. You're more likely to encounter someone that's immune, and so it won't create that problem. That is our hope. Now, I will say this about the Chinese. I hope you're listening on the internet since I'm such a big influencer now. Their vaccine that they produce, the one that's being used in Brazil right now, they say it's only about 50% effective. And from what I read this morning, the Brazilians were very upset about that low efficacy rate. So that is something to consider. What type of vaccine are you getting? And really, this is kind of one of those, I don't know if you want to call it a social justice issue or how you want to refer to it. But basically, the more money your country has and more it develops stuff, the more quicker and better you'll get vaccines and medicine. So, I mean, we do have that benefit. I always tell you, Walker, you won the lottery when you were born. But I feel bad for people who are getting vaccines that aren't very effective, or who knows what they're told, to be honest with you. All right. Any questions about the vaccine? So as I find out more stuff, I'll be glad to let you know. Now, I will say this, because I know there are some people who are concerned, like legitimately, not like weirdo concerned. There has been some side effects associated with the vaccine, just like almost any vaccine. And what are some of those side effects? Y'all heard? One of the main ones that's discussed is allergies, like having a severe allergic reaction where you need like a EpiPen stabbed in you. That was actually a warning that was pushed out when the vaccines came out, that if you already had like an EpiPen for some type of food allergy or something, then you were much more likely to encounter or have an allergy to the vaccine. So you need to be careful. The article I read the other day in Chicago something or another said that 29 people so far had like a severe allergy to the vaccine. But that was out of about 5 million people, which means about 1 in every 180,000 people. So it's one of those things where, you know, if those 5 million people that got the vaccine got sick and the death rate is 0.1%, which is, I think, about where the flu is, so about 1 in 1,000, then 5,300 people would have died. So you've got to weigh, you know, you got to make a cost-benefit analysis there on what you're going to do and whether you're going to get the vaccine or not. Okay, so be educated and be responsible and think about what's best for you. Nothing's foolproof, but hopefully you guys will at least know the pros and cons there. I mean, there could be some long-term side effects that we don't know about, but I don't know that we suspect that or there's a high likelihood of that happening. Okay, any questions? Viral genome. So viruses have one or two things on the inside. What are they?
DNA or RNA.
DNA or RNA, good. And so RNA is kind of weird because that means they are retroviruses and they have to copy their RNA into DNA using what enzyme?
DNA transcriptase.
Close. You go backwards. You know, reverse transcriptase. You copy that RNA, like, so think of herpes. You've got RNA, you got to copy it backwards into the DNA, embed it into that cell's DNA. So you get in a cell, you copy it backwards, you embed your DNA in the cell's DNA, and then on one of those days, it's cold outside, maybe you get a little crack in the lip, that cell gets aggravated, and it's like, let's make some herpes viruses. And so it starts making a bunch of copies and puts them out there, and you wind up with a cold sore, and that's because all those cells have basically made thousands of viruses, and they're exploding, and viruses are going everywhere. So, yeah, don't make out with anybody with a cold sore. And as the commercials used to say, Valtrex, it's all about suppression. It's one of those antiviral drugs you see a lot. All right, see what else. We talked about the different components of a virus. The viral envelope is really, like I said, the most important part because of how it acts like a Trojan horse. Let's get a little philosophical here on part D. Viruses are not living organisms. So, sorta. I mean, what do you hear people say about Lysol all the time? Kills viruses. Yeah, it kills 99.9%, right? How can you kill them if they're not alive? This is one of those things where it's kind of like hard to define. Typically, we think of something living as it can live and reproduce and grow, and there are functions going on inside of it. When you've got a virus that's just like DNA or RNA and a protein code on the outside, there's nothing else that's going on. You have to have a host in order to replicate and spread that stuff. So in that case, it's not really like most living things, even though it's made up of organic molecules that most living things are made up of. Okay, so I would say it's kind of on that cusp of living and just some molecular material.
Isn't the other criteria that has to adapt to its environment?
Well, viruses do adapt to their environment, right? Mm-hmm. So I mean, if you look, I think in your 9th grade book, there's like 8 different criteria for living things that they usually list out. And then viruses only come up short on like 1 or 2 of those. And I know what you're thinking. Well, a lot of parasites need something else to replicate and live. Well, they do need something to replicate and like pass on their traits. But I mean, if you have like a parasitic fungi or something, the cells can still be alive on their own. I mean, they may need to get food from something and they just can't get it because they can't parasitize it, but they're still alive. They can live for a little bit anyway. It's not like they don't have any organelles or parts that can function. So, tomorrow, I can only tell you this is going to get more complicated. So, tomorrow we'll finish up Biotech Part 1 and hit Biotech Part 2. You guys have a quiz online. The quiz online is due Monday at 11:45. It's on AP Classroom. It is about 20 questions. You have, I think, 25 minutes. It is on everything up until biotech. Okay? So you guys need to get on there. I would try to take it like a quiz without any notes, without any help. When you're finished with it, before you submit it, go back. If you had trouble with questions, you want to look something up, feel free to do so. And then submit it, and we'll see how you did. Okay? I will see you guys tomorrow. Take care.